So an interesting thing happened. So a few weeks ago, we put out a video on our second channel, Pierson Plus, which is really a deep dive into the working principles and the application of lean around our company, Pierson Workholding. Now, this video was just a raw, uncut version of one of my mill operators, Paul, wearing a GoPro, just doing work around the shop. Now, it surprised me because it actually got a lot of views, and even more surprising, it got a lot of interactions in the comments section. Lots of questions were asked. So in this video, I'm gonna head back into my office and watch the video, and I will add my commentary to this raw footage. Now, a few things to keep in mind. We did not edit this in any particular form other than just speeding up some sections that were redundant and boring. And we left in some real life struggles that shops face on a daily basis. Now, we're not perfect, we don't claim to be, but I wanted to show you how we think through some of these problems, and hopefully it will inspire and be of value to you guys. So at this point, let's head into my office and let's take a look.
So Paul's been with us, first of all, for about, I don't know, 6 months. And I always value new employees because they see things that more seasoned veteran employees don't see. Things like waste specifically. So we're really big on training people about the 8 wastes of lean. So, you know, here Paul's he's getting set up. It's kind of not first thing in the morning. We're maybe 2 hours into the workday, but just kind of getting oriented on a new task. So we'll watch this all the way through. I'll comment along the way, but notice that Paul is actually doing the work of maybe at least 3 people. There's one machine here, it's our EC400, and then we have our VF2-SS, and then we have our inspection stuff. So in a corporate shop, you're gonna see stuff like a proper CMM room, which we have a CMM. It's funny, he's moving over to help Alex wrap a pallet.
Yeah, pay no attention to me or this.
Yeah, he's, it's funny because maybe he's doing the work of a 4th guy here, like a shop hand, helping to wrap a pallet of complete parts that is ready to go out to Standardize. One thing I'll mention is we standardize our pallets. So years and years ago, we had an old recycled wood pallet where we put good finished product going out specifically to heat treater, and it came back, and because we used an old wooden recycled reused pallet, what was happening was there's not a value conveyed in that junky pallet. What we got back was an even worse pallet that had nail heads sticking out that damaged our work pieces. Now we covered, on the way out, we covered it with 2 layers of cardboard. On the way back, they just put our raw machine parts on the pallet. And we were like, okay, we're never doing that again. Investing in plastic pallets just conveys that, hey, these aren't just your run-of-the-mill reused, recycled pallets. These actually belong to us. If they go out on plastic pallets, they're coming back on plastic pallets. So our EC400 has a pallet pool. It holds 7 pallets. So we're Pierson Workholding, so we use our own pallets for our Pro and Mini pallet systems, along with our RotoVise has pallets as well. But this is Haas's pallets. And you'll see this is kind of cool because we have taken our Pro pallet system and we've put it on 4 sides of a tombstone and productized that. So that is now our horizontal pallet system.
Alex, can I take this cart? Huh?
Yeah, go ahead. No, go
You
ahead.
sure?
Yeah. Oh, yes. Are you gonna need it for the video?
I was just gonna, no, it's just putting op zeros somewhere. I can maybe consolidate this. I can consolidate onto one of these.
Okay.
So real world scenario, like we're a machine shop. There's messes. There's work in progress. There's products that have gone out, gone in, are in their staging
Maybe this one.
area, ready to be assembled, ready to be processed, that type of thing. And so we have standardized with steel welded 2 shelf carts from Uline. You'll see them everywhere.
Everything is kind of being used.
Everything is being used. It's kind of a good problem to have, right? Maybe, maybe not.
The only reason I don't want it on there is because it's gonna sit there for a while.
Yeah, it's gonna
And I'm gonna need that cart.
for sure.
Yeah, maybe if you grab one of those.
Yeah, we have some consolidation that can be done.
Good. We have excess inventory of carts. So the guys are talking about like trying to, what can we do? How can we consolidate?
This is almost done.
We don't want to, the answer to the solution is not to buy more carts. Maybe it is, but in this case, no. There's some waste of unused inventory.
Oh.
And it looks like we found a solution.
I would put these on that cart, the one that you're gonna take off.
Uh-huh.
I'll put these on there, and then because these hold more, so just start stacking these on here, and then we'll have an empty one at the end.
So these on here.
Yes.
Yeah.
And then put them upside down.
Okay.
So with the machine side down, because that way when you go to machine off one, you just have to grab it and put it in.
Yeah, easy.
You don't have to flip it over.
Cool.
Yeah. And
All
then
right.
you could put the same 2x3, or 6 per layer, because it'll fit, and then you don't have to worry about the finish because it's gonna be machined again.
Yeah, we'll just load it. Okay, cool.
Yeah.
Did you guys catch that? That pro tip that Alex just dropped? So when op
You can
1,
actually just load these on a fixture.
Just load,
You don't
yeah.
have to necessarily run them.
Just put them in.
And then that way you don't have to take them out.
That's perfect.
Yeah. Then you have all-
Cool.
2 things here I'm going to talk about. So Alex is telling Paul,
4 and 6.
3 and 4.
3 and 4.
figuring out
Okay, I'll start with 4.
which Haas pallet it goes on. So what Alex is helping Paul with is to determine like, hey, let's free up a cart. Where can we put this stuff? Well, the best place to put stuff is into the value stream, like into a machine. That's number 1. So he's saying load it into a fixture. That will free up a cart. So we're only doing that work one time. We're taking, it looks like he's making 8 pallets here. He's taking them off and he's putting them in the fixture in the machine. We're not yet ready to run them, but it'll free up a cart and it will put us further down the line in production. The other thing that that tip that you heard, that little ka-ching sound, what Alex said to Paul was, hey, when the parts come off finished, put them on a cart, but don't put them face up, put them face down. That does 2 things. It protects them from dust, from other things like that. You also see that like when you're putting parts face down on a cart, I'm going to say cart, a lot of people will use a workbench, but Pierson ecosystem, it goes on a cart. You see the surface that it is going on. You can see if there's chips, debris, that type of stuff. When you put a part face up and then you go to a second layer, you may put a piece of cardboard down that may have embedded chips, dirt, grime, that type of thing. When you put it face down, number 1, you know where it's going. Number 2, it naturally drains out any coolant or chips. So you get this natural draining effect. And number 3, when you go to put it into the machine for Op 2, it's already oriented face down. You don't have to flip it over. So you're going to eventually have to flip it over somehow at one point or another. It's just easier to just do that work up front. And if you're not doing the work, someone else is, great. You've made their job just a little bit easier. So this is pretty cool. So we don't use the term SMED, which is single minute exchange of dies. We don't use that around here because it's too corporate-y. It's not, I don't know. It's easier to just say, hey, let's try and move this along and eliminate some waste, whether it is weighting, which is a time-based weight or waste. But this is a SMED application. So if you just saw there, Paul, we have one fixture that cuts either 8-inch or 10-inch wide pallets. He just moved our rocker clamps up, and he went from an 8-inch configuration to a 10-inch configuration. Now notice when he grabs this next part, he looks for the better side. The better side goes away from the operator. That's the finished side that the customer sees. And then he reaches over and he grabs these green things. So those are 3D printed, what would you call it? Part stops, work stops. Basically, they're different lengths. If you're making a 16-inch or a 10-inch or 12-inch, 8, what's another size we do, 6, long pallet, instead of getting out the tape measure or the ruler and having to read it, instead, we just 3D printed these work stops. You just grab the 16 and you put it up, and there's your work stop. So you don't really have to think about it. Okay, so what Paul did there, it's easy to miss. He finished loading parts, and he's calling up the next pallet on the EC, the machine behind him. So it's running, it's moving pallets. Meanwhile, he's not waiting for that. He's not watching it. He moved right over to the VF2-SS, which just finished. Now he's at our granite surface plate with our Trimos digital height gauge, zeroing it out, taking a reading. Hard to see, I know, when it comes up because of the glare, but that reads 0.9940. Drawing is 0.994, nailed it. Also, hey, did you notice that? He took a Sharpie and drew on a little pad of paper the dimensions that he needs to check. Now, normally we would have, which we do have a production drawing. We have it up on the screen, or we have an actual physical drawing that's magneted up to the machine. But on this particular part, it is, I think it is a prototype part that we're working on for our Vise pallet. Working name is a Vise pallet. We'll rename it at launch day. But he is checking that 0.994 height of the part. And so instead of looking at a drawing and hunting around or highlighting or circling, he just sketches it out just to make it big and bold. And then he goes in and he's able to just know exactly what he needs to look for. It's kind of like Cliff Notes for drawings. So the other thing is, why would Pierson Workholding, a high-density workholding manufacturer, use a vise? Well, we're prototyping. We're doing a first production run. We're doing under 100 parts. We want to prove that this component is correct first before then graduating it to a dedicated fixture. But you'll also notice that we take our vises, and here in this case it's a 6-inch double vise, and we palletize it on one of our pallets so we can do those quick changes. So we don't have to fuss with, when we do use a vise, we don't have to fuss with indicating it, getting the offsets. All that is built into the model in Fusion, so we can just pop on the vise that's already on the pallet, registered. The origin is locked into the machine. We basically draw it up in Fusion to reflect reality, and then we're done. We're ready to machine. Hey, while I was saying this, look at that. Paul just did on the second set of Haas pallets another SMED, single minute exchange of dies, to change it over to from an 8-inch to a 10-inch wide pallet. There it is. There's that 3D printed stop, which gauges the pallet. These also go in and they're probed on 5 sides. The surface to find out the deviation from where the origin, the Z origin, should be. And then the X and Y location, which gives us the center of the workpiece, which is our origin. Oh, also notice here, he mixed them. A 16-inch and a 12-inch pallet. That's fine. Our probing cycle will account for different product sizes. He can do something as small as our 8 by 14 inch mini pallets, along with our largest 10 by 16 inch pro pallets. And he doesn't have to change programs. We've eliminated all that error. He doesn't need to change programs, worry about origins. He just puts them in, and a master program, which is a probing cycle, will go in and find out what is in each station, and then load the appropriate program to cut that individual pallet it's amazing. Does it take more time to probe? Yes, but we don't care about that because this is our brain shift, our day shift. A lot of these things, you'll just load them and run them lights out without any cares or worries. We're going to get, even if we get half of another shift, we've already processed 8, 12, 16, 24 pallets, essentially lights out overnight. Yeah, a little bit of struggle there. The clamp was closed a little too much. He couldn't get it in. That's why he's having to reassess that. There you go. Perfect. Beautiful. Get in the gauge. Space it out. Hold it in place. Impact driver, Ryobi. We'll do another video because this is, notice he's using 2 hands to turn this tombstone. That's an aftermarket thing that we put together so that you could unlock the tombstone via foot pedal. Kind of caught it there in the lower left-hand corner if you go back a few seconds. Called it Pallet 1. Okay, tending another machine, our UMC 500. Here we're using our RotoVise in our, so we've got a little stack up here. Our RotoVise is attached to a Max 5 pallet. So we have the Max 4 that's publicly available. Max 5 is a prototype we're working on. It's meant for larger work envelopes like 5-axis machines, UMC 500, 750, all that good stuff. This is interesting. So we use kind of an off-the-shelf part locator. I don't remember what it's called, but what we did is we embedded some magnets into it. RotoVise is a cast iron and tool steel, depending on the component. So everything's ferrous. So you notice that it's just held on by a magnet. And of course he verifies that we would never just have him like load the part without holding that you can see with his fingers. Kind of holds it in place. It's just kind of like a second hand, if you will. Good stuff. I have plans to automate this machine. We bought it. It's not automation ready, but shout out to Gimbel Automation. They've made a really easy product called a IntraLoad, which allows you to add, probably in our case, minimum of 9 pallets, probably more like 12. I think it maxed out at 15, where we would go individual pallets. And they've standardized with our Max 4 pallet system. It's basically a rotary pallet system in their machine as their standard offering. We're actually making the valve bodies here for our vacuum power unit, which is another product line, Smart Vac line. Okay, and while he was doing that, hey, look at that. It called up another fixture. So we're not waiting for things. It's too common to say, hey, we're not wasting time. No, we're eliminating the waste of waiting by doing simultaneous work. So this is something, one of my other guys said he was at an oil change shop and he was watching the 3 technicians fight over a specific diameter of socket wrench. And my thing is, like, if I own that shop, you just go buy more sockets, you know, not the driver, the socket. I mean, we're talking like $5 to $10. This is making what's called the Op 0, or the preparatory operation of our Pro Pallet bases. We do this to remove the majority of material that we carve out from these, because we've found that to do that allows the material to relax a bit, and then we can go into a proper Op 1. So this is just hogging out a ton of material. It's pretty fast. It probably removes about half of the volume of the material. And this is a, what is it, a 12-inch by 8-inch by 2-inch piece of extruded aluminum. And it probably takes about half that volume out of it. And then the material is known to, you know, do some weird things. So we just rough it out, probably leave about 100 thousandths on every side. And it just makes a better product that way. And anything that doesn't add final value, not value, final aesthetics to the part, we call that a preparatory operation. And any preparatory operation, we just call it Op 0. You'll also notice in the lower right-hand corner where, when Paul is holstering these, we have two screw guns. I bet one is being borrowed right now at a different machine. But if we're working with the fixture with two different types of clamps, maybe we're doing an Op 1 and Op 2 on different faces of our horizontal pallet system. The Op 1 thread, socket may be different than, you know, the thread of a different socket. So that's why we have two screw guns. And then we're not changing bits or anything like that. We're literally just holstering and unholstering two different guns. We also keep it close so we don't have to like turn around. We don't have to, we're basically minimizing wasted motion. That's another of the 8 lean wastes. The nice thing about horizontals is you don't have to blow off parts you don't have to spend a lot of time blowing off parts. The coolant just naturally drips down. It minimizes that really over processing of blowing off parts that are just going to go back into the machine and get blown off later, or really soaked with coolant and then blown off later. Well, there you have it, 20 minutes in the life of a machinist here at Pierson Workholding. If you like this content, of course, subscribe to this channel or check out our second channel where we post more of this deep dive content. That's called Pierson Plus. Look for it in the description below. We'll post a link for sure. So until next time, go innovate your production.